All right. Another concept that has to do with the application of Wheatstone Bridge is the Metre bridge. So we're going to consider this topic as application number 2 of the Wheatstone Bridge, which we earlier treated in our previous video, right? Then before we consider all that, we need to understand how this works. This is a schematic representation of a Metre bridge, which is a practical application of the Wheatstone Bridge. We won't go into details now, all right? But let's just see how simple this can be in explanation. Now, the first thing we need to understand here is, as usual, we have the cell. That's the first thing. There's the source of energy here is the cell that powers the system, right? Supplies current. Once the key closes, current flows, all right? But the current flowing here is very, very small. Why is it small? Because we are considering the fact of the amount, the energy power, the energy given by the cell, right? The resistance of the circuit, and so on and so forth. And it's because of the smallness of the flow of current in the circuit that we are using a sensitive device known as the galvanometer. So what happens here is very simple. Inasmuch as we have learned that R1, R2 is equal to R3 over R4, that applies if we are solving problems involving Wheatstone Bridge. But this time around, this is extended to finding the unknown standard resistance here, Y, all over the length here between this and this point. Maybe we call this point K, right? Okay? The balance point, that is Y over AK, all right, is equal to the known resistance given us 20 ohms is 20 ohms, right? All over. What do? AK, AB, look at the entire length, okay, is calibrated in centimeters. The entire length is calibrated in centimeters. And it has a total length of 100 cm, from which 40 cm has shown a balance point. Oh my goodness. By the time you understand this, it makes sense to you. Let it become pleasurable, right? All right, so with that, let's see what happens. We have AB, which is A, B, but there is, from this AB, there is an extraction, AK, that is minus AK. So look at this in detail. Remember, we are talking about this because we want to find the unknown value Y. We want to find this. Can you see the similarity? This applies in Wheatstone Bridge. These apply in the practical application of Wheatstone Bridge, which is known as Metre Bridge. And that's application number 2. All right? Good. So before I continue, if you have really found value in this, why don't you subscribe? Why don't you give us some thumbs up? Share with your friends, networks, students. Oh, lest I forget, put on the bell button for constant notification. Of course you know that. All right? Thank you for doing all that. As well, I want to use this medium to thank my returning subscribers for staying put. And then my new subscribers, come on. You will learn a lot here, okay? Thank you. So let's move on. Chalk. Let's take one more chalk and continue our analysis here. So we have understood this. So this is absolutely what this means. If we understand this, then to find the value of Y, which is unknown, is very simple. Very simple. So what do? We substitute accordingly. We move on and substitute. So we start our substitution somewhere here, because we don't have anything to do with this. We don't have anything to do with this, but we have something to do with this, because this is the practical application of the Wheatstone Bridge, which has been fashioned into the meter bridge. So let's see how it goes. It goes this way. Y is the one we are looking for. AK is 40 cm, alright? 40 cm is equal to. Then we have 20 ohms standard given already, so we are not looking for it. So we substitute 20 ohms all over. AB is the entire length of the meter bridge. The entire length from here, from this point to this point, is 100 cm. Alright? So we put 100 cm, alright, that's the entire length. But from A to K is 40 cm. We put minus 40 cm. Enclose it. Okay? That becomes very simple. We move on again. We are looking for y all over 40. Simple manipulation here gives like 400 minus 40. 100 minus 40 is going to give us 60. Okay? That's what it means. And if we move on again, we now make y the subjects. By the time we make y the subjects, I want to picture. By the time we make y the subjects, we have 20, all right? 20 times 40 all over 60. So let's see. 20 times 40 all over 60. That's what it's going to be. Now, if we do the remaining aspects of a simple arithmetic operation there, we have the answer as 13.33. Okay? Because 2 times 4 is going to be 8. So we resolve it. Then by the time we have all that, 20 times 40, what is it going to give us? Very simple. So if we do that, let's just see what we're going to get. If we have 20 times 40, I want to be detailed in what I'm doing, right? 0 times 0 is 0, 0 times 2 is 0, 4 times 0 is 0, 4 times 2 is 8. That is 800. Good. We have found that 20 times 40 is 800. 800. It's not difficult. For your learning pleasure, for your understanding, I'm doing this. All right. But if you think my steps are a bit confusing, put it in the comment section. I will address it in my next video. Put it, comment it in the comment section or comment box. I will address your concern. It's my duty, it's my responsibility as a teacher of record. Okay, let's get back to this. Now we have that y is equal to 800 all over what? 60. Good, so we have all over 60. What do we have? Cancel out, we cancel out. Okay? That's it. If we take another cancellation, we are left with y all equal to 80 all over 6. So what do you think happens here? 2 can go, of course. 2 goes, we have 40. All right? 2 goes against 6, we have 3. So what do you think happens? Finally, if we do all that, y is equal to 13.33 ohms. So what this means is that the value of the standard resistor that must be connected at this point must be 13.33 ohms. That's what it means. Come on, understand that. So I want you to take your time, learn the steps that I have outlined out so far, and then if there is any confusion, put it in the comment section. I will address that to your concern. Thank you so much for watching. So carry this, substitute here, we now have the value of y. And that's very interesting. So what happens? That the boiler's point, by the time y is connected, and this is maintained as it is, we have this value point. That is what it means. Remember also that the meter bridge also measures, compares two cells. We will come back to that. In my next video, I'm going to connect or link application 3 that has to do with meter bridge. So stay put, remain subscribed, share with your friends, students and networks, do not forget once again to put on that bell button for constant notification. I am signing out.